already in Google an important team, and we really want to establish this like finalization of WebRTC and come do our responsibility of that and making investments there. So just one a large part of this has been testing. So today I will go quickly over our efforts there and how we work together with Alex and employees on getting the right testing in place. So what we've been presenting a bit over a week ago at Cranky Geek, which is an important event for WebRTC, is that like our path towards WebRTC 1.0 is much more than spec itself. There's a large part that includes testing, get all the browsers up to date with specs as they have evolved, and to make sure that they work reliable. And we've seen that like video communication on the web is hard. Making it work 95% of the cases is not enough. And as we see today, we spent like half an hour to get this system set up. It's like making it work reliable is like such a major part of actually providing this API on the web. What we also communicated is like the long road that we've been through to get to WebRTC 1.0, that we have like tons of spec work and collecting protocols on like both IETF and the WebRTC side, and that most of those are actually completed or nearing completion. There's some work to do on statistics, but a lot of them are in the states now, and it has taken a lot of efforts to take all these pieces together. With WebRTC, what wasn't here last year, I think what was recognized that web platform tests, although that's a great tool for testing web standards in itself, is not the special situation that WebRTC is in the sense that we have a complex system with a lot of new lower-level protocols interacting with each other, and these protocols are often not really tested themselves individually. So at Google, at least recognized the need and followed up like a good idea from Alex to build a separate system for testing end-to-end with across different browsers and different operating systems, making the systems of neutral and extendable. So that's the reason why we launched Kite, and we formally announced it last week as an open source project. And we hope that this can like fill in non major gaps in their testing efforts. More about this later. Like the third part, so we have the tests, like the spec itself is compliance. So all the browsers have their own challenges with becoming compliant with the WebRTC 1.0 spec, and like on Google side, we have Chrome had quite some to do some updates. But through the past year, we managed to actually get a lot in place. Working towards new API for static and stats, getting media stream track constraints working, and starting to work on the receiver, later sender, consumer topics, adding track. So a lot of this is in good progress and is landing, both in WebRTC and in Chrome. And like the most major milestone will probably be when we get to Unified Plan or Q1 next year. What the feedback really from Cranky Geek, what you see is that like because we still have a lot of these issues with compliance, that there's like a lot of developers are starting to be more appealed to make collection based proprietary systems, and that's why we believe it's so critically important to get to this zero as fast as we can now for the industry. Fourthly, like I quickly mentioned, we realized that if you look at all the stuff within Google towards WebRTC 1.0, actually the majority of engineering are working on making it work reliable. Spec implementation is one thing, but making it really feel safe is a lot harder in overloaded systems, complex browsers. You have garbage collectors running on the side, kinds of media problems. So this is hard to get right, and we spent a lot of research on. And we also know like that in other browsers like this, like right. So we'll be very clear that even when we reach tracking compliance, that we'll have some lag in actually making it work really well. So yeah, with that I want to like give it over to Suarez, who has been working and sponsored by Google on getting last week's update. Ready update.
Hi everyone, my name is Suarez. It's my first time to tech, so pleasure to meet everyone. So here I'm going to give us a quick update compliance testing platform test. So in the beginning, the test for the WebRTCs that we have had a few tests written and month added
Sorry, guys.
1,000 tests with PT. And we have added one more approach to calculate how much coverage we actually have for the WebRTC. And the way we calculate is by writing out all every one of the normatives by mail format, and then write a status for each of them and calculate how much is the statements that need to be tested. So this is the first time we know that there's about 70% tested for RTG. So more information you can go into the 8. There are a few challenges that why we feel a bit more to coverage. So so currently we have about 134 that we still haven't tested because we miss it out. But there's a bit difficult track of what is tested and what is not until now. And also the tests are currently written in the June draft, which since then there has been quite a lot of updates. So then the tests are a bit out of sync. So hopefully the test that you commit, so we hope those are tests that involve race conditions, and those require a bit more effort to test them correctly. So in WebRTC, there's a few steps that is taken into special consideration that are on happening in concurrent. So it's like, for example, if two steps are happening in parallel, like the connection closed halfway when some other operations in and some steps are aborted. So then, in order to test this, we such that these kind of concurrent operations would happen in the order we have set, so that we can see that the behavior is such as the algorithms are aborted halfway through.
Another question. In terms of reaching in the previous slide,
So about 10% that are untestable. So, you didn't list that on the 100%. What's your plan for the untestable? Yeah.
So,
We're going to discuss that later. That's fine.
so the untestable is mostly due to the restriction of JavaScript. So because those are involved in, for example, the native behavior of the browser, which the JavaScript don't have information, don't have access to that kind of information. So then, from if we are just writing plain JavaScript text, it's not possible.
So the reason I'm asking is from normative statements in the and this might suggest from normative statements in the specification itself, it might suggest that there are some modifications that will need to happen in the specification so we don't end up with untestable tests.
There are a few that will never be able to, as like a JavaScript level, to go, for example, to where some of the errors should be in the spec because the browser implementers have to deal with it, but you cannot test. So I don't think there is a fundamental problem. The question on the promises. Have some part of the text where one action is supposed to generate a promise. For that promise is returned to do something else.
Excuse me. Yeah, right. That should actually be specified. I mean, probably running into bugs in the present.
Just showing an example of an algorithm where the timing
like, for example, closing the peer connection. But I agree with your statement. That sounds like it might be underspecified.
Right. Well, you mentioned promises, but I don't think that's unique to promises. It sounds like it's even when we have callbacks, it's still an asynchronous API.
correct.
So there will be inherent timings.
That's the
way
question.
you go.
I thought the answer was good. I understood it. I was thinking of different types of race conditions where, like, ice in it, like, I'm just going to happen, something will happen. These types, but these.
Another addition to the question, right now the untestable are actually accounted as tested. Testable are actually of that arbitrary, but like what we should. Right. The last comment I would like to do here is that let's add in 97. This is basically half of the might be, exactly saying how. And most of these 97 here are things that were added. Process of testing is actually discovering new problems, not adding new features. But hopefully we're catching up faster on testing. Um, 100%, 90%, maybe 10%, that will be slightly more difficult, but usually, it's not less, that's for sure. Reach 100% by
Yeah. reach 100% for WebRTC. There's still more things to note. So the first thing is that coverage does not imply correctness. So, so not all the tests written are like correct by default, and they still need validation by the implementers and stakeholders. So if you find out any issues that the test does not seem correct, please out. So yeah, so the PR 82 of the way we
you can basically
you might also want to discuss more about how we actually want to move forward on keeping track of this coverage. So after this, we are also starting another effort to do the automation integration with the WebDriver and permissions API, in particular on the get user media API. Other than WebRTC PC, there are also other specs that need testing. So we are on track on testing the media capture main spec next and trying to make it 100%. And there are also some other specs in the pipeline, such as the recording depth and element. So these are something that we put out for collaboration from others.
Right. So I think complicated. There are several angles to it. The compliance part so far, which is really testing. But there are some of the cases that need. So I'm going to speak about real-time communication testing, taking the example of WebRTC, actually applying to WebRTC. So, we all have different kind of apps or even devices that depends on running browsers to have the right API and be able to play. We just spoke about the JavaScript API compliance, and that's pretty much the way people test the web application today. Our case is part of the standardization process, so we have to do it. Tests are standalone tests, and the interoperability is my web application, whatever the browser and whatever you on at the time. And I'm looking at a lot of different browsers and we're obviously there where no JavaScript API is. And so I didn't have a need to test that. So what about WebRTC 1.0? WebRTC 1.0 API was only tested up to 10% last year. But some of the remaining 30% require a little bit different. Of course, you can know some parts were just written, they draft as usual, was issued one day before meeting and things like that. But eventually, there's still a bucket that says, I need addition of interoperability. For example, of the thing that you can test completely everything that touches the network. From here, I'm being wrong enough. But also and try to do an exhaustive. A lot of people were trying to do that. That's that problem. But
only one of the kind of problem that is on. But I'm going now to make the difference between by definition, compliance requires interaction automation with and the non-test of the single probability testing still require interaction automation with at least two instances equivalent to each other of the same test, running in at least two browsers in parallel. That's a completely different state of test will be whatever it wants. I'm not going to be writing the test. I'm going to define the type and try to crack the problem. So let's look at interaction automation. WebDriver is around. It's a fantastic tool. A lot of people have a little bit of differences between the different implementations. Yes. Right, I can do that. The Microsoft, I think it's Edge driver and Safari driver. And it's actually so successful that people started to provide Selenium nodes as a service. I call that browser as a service. If you don't want to make the whole version of the browser on all the operating systems, and you have some companies that make them the business model to actually provide that as a service for you. Next thing is much easier to test, but they're still testing it the whole way. I'll get back to that later. Of course, WebDriver is not perfect. For example, it's not handling the permission prompt. So the first thing that's on your way when you want to test WebRTC is security prompt. Security prompts are not part of the web page for security to access them. So they're part of the browser itself. And as such, WebDriver by default doesn't know how to interact with them. There is ongoing work in the Web2 working group to actually extend WebDriver to be able to handle the 8 or 9 different permission prompts we have. It will do the microclients. And of course, with a little bit of added work in the case of get user media, because that permission prompt on get user media is actually a proxy for a lot of security for the staff. The type of candidate is going supposedly depends on and so on and so forth. Once you have passed that, the second problem you have if you want to test WebRTC is video to media on virtual machines or something that might not have a webcam on any kind of acquisition device. So Firefox and Chrome have solutions around that right now, but the idea would be to standardize a way to generate fake deterministic media through a WebDriver protocol in such a way that you could have a test that works. That's ongoing. So if you wrap up WebDriver for real-time communication, it's great for interaction. It can handle multiple browsers in parallel, but it doesn't know how to synchronize the test as well. That aspect, Selenium was times my web application on different browsers to check that the behavior and the loop of my application is the same. And they focus a lot on backward testing. So people have a web app and want to make sure it's still working on but they don't have an What we want nowadays is really to test the browser as early as possible with Firefox 19 and so on. The stable version of the browser, in which case there are these 4 critical and famous bugs in Chrome 58 that were fixed, but they have to wait until 61 to actually see it. Deep a little bit area as well, and that's not something that WebDriver or Browser Stack and the other vendors are going to help us, at least for the time being. There's a lot of tools out there addressing a subset of the problem, which shows that the problem exists and people are working on it. Some of them are commercial, some of them are open. Specifically, WebRTC SFU, like a little bit more generic, but that shows that the problem exists. For people to yeah. Okay, existing tools are limited. All that can be, right? Should I really? Okay, so let's take a look at the people that were here at TPAC last year have already seen slides, but that will be a reminder. I want to try all the possible there because I'm just going to take a one-to-one call, you know, as a base. People want to do more than that, but let's talk simple. And I want to see all the browser of interest on all the operating systems. I have roughly 500 cases. This is what I want to test. 500 pairs, right? This is what I could test before Kali, right? Only one operating system at a time. So that's only 20%. And that's what we were actually testing, which was Firefox and Chrome. This virtual actually be that good. That was good. So it was really bad. But okay, now let's do the groundwork and test and meet all the tests and all the possible use that we want. Some people want, develop Electron, develop Chrome, browser developer, and one version of the browser on the machine. They want to be able to test that. All usually triggered and local. Some people want to have something that is copy-paste, and fast, and so on, continue. Pretty much what was done for years and them a little bit more time and they can do it in a week. Integrate it maybe in social. Be able to support that. One different type of node as well because of the others I'm going to test. Apple hardware to have a Mac OS and iOS. I will not find that in the usual provider. You will not find a virtual instance. But you need to find another way to get to be able to test on Apple machine. Browser stack is nice, but it's only going to give me little browsers and browsers. If I want to test in Canary and so on, that will be more challenging. Windows Preview is fine on some of the vendors, but not all of them. And if I'm writing extension for script, or if I'm writing plugins for Explorer, or if I modify the browser in any possible way, I will not be able to use that. I could go down the list and show you the cases covered, but the idea is you cannot get away with only one kind of selection. So handle hybrids in memory. Local machine, browser stack, and so on and so forth. So you look right at which of the operating system you want to support. Here you have the drawing, the statistics for all the go-to family for the year 2016. If you take all the go-to software, go-to meeting, and so on in 2016, almost 80% of the people are on Windows 7. The biggest one would be Mac OS X, Android, iOS, and finally Linux. And there is no Windows 10, there is no Edge. And so that is actually Internet Explorer. So that's the enterprise snapshot. Look at the tricks from social websites or so on, you will see a very different distribution. But when you want to address the enterprise market, the folks are completely unique to support Windows, which may not support whether it's a 7 or 10 is a discussion about the target audience, but Windows needs to be in the lead, whatever. Rather, well, Chrome and Firefox are coming for free. They're easily testable on this page. Safari would love to. Practical in the sense that there's not a wonderful clusters, on Mac server that exist anymore. That X server from Mac that was one new rack does not exist anymore. I have a ashtray, trashy looking thing, a processor and 12 cores, or a big screen with hardware inside that is full operation. And that's the only machine I can run a virtual Mac OS X on. I can only run a Mac OS X virtual Mac. Kind of limiting. So it's possible that you need to have a specific setup in your grid to actually be able to do that. Edge, yes. WebRTC, what's your flavor? You want the first stack, the second stack, the one in Edge, the one in native, and so on and so forth. Eventually, beyond the question of the browser, there is the fact that the WebDriver implementation of Edge does not have any option to either bypass or support the permission or I have virtually failed in my communication with the WebDriver people at Microsoft to convey the importance of that. Internet Explorer, yes, it's important so that it's for the enterprise market, but then the question becomes, all right, how early do I want to test? And the answer, as early as possible, key for the vendors and once you patch quickly from the need to catch the problem, provide a patch in the canary version. And for so I don't know exactly for as a very tech review and so on and so forth. They are only invited to use the Microsoft for then do I want freedom or convenience and how much am I ready to pay? Some people really want to control everything and don't have the resources. But also the people who might not have the capacity. The idea again is you might want to have control. Have resource. In all of these metrics, we start evaluating plots. First part you see, I think, is hard, but again, it's only hosted. It's only doing Chrome and Firefox, and last time test Linux and services, so I don't. Try this. I put it as an example. WebRTC and it's only hosted. It's general Selenium nodes, so you have the version of actually creating the version of the browser and set that code online to do it, but sure, though it's very limited. That could go on and go through. But basically, I think as I would say, I want everything right now. So, but most of us have been around a long time, especially for Don, Harold, and myself, who used to write tests alone in the park when nobody else was. Testing obviously feels like death by overload. You feel you fix one, and then there's something in your own. But then what hiding time and it's never ending. So by the time we fix everything, there's another step that came out too. So we created an interoperability testing engine just by overload. KROC interoperability testing and that we have. One is generic in the sense that we didn't want it specific to something. They all took a different approach. What we wanted to do is copy that need version of the browsers to each other, whether it's only chat or actually WebRTC or something. And it could be backend, yes, part one day, I get the data. We should platform and any client on the engine. It is reusable, any kind of integration process, any kind of trigger, and we want it mainly the project. And of course, stable data that can be internet purpose of running on premises, with your own cloud, or hosted by someone else. So that's everything. So the easiest way to achieve that was by divide and conquer. Thirdly, we wanted the test engine to know nothing about the test or the dashboard it was reporting to. Right? It just was running, the dashboard it was reporting to, all the Selenium grid was set up, what kind of Selenium node that was using, should be totally transparent to the grid. The test itself could be anything as long as it abides by the Fuel interface. So that allows for everybody to write tests that run on top of Kite independently of the platform and then the final data. And finally, you should be able to wire in a dashboard. Right? So one day you might want to be able to run it with data with a limited configuration, right? Because it needs to stay within 20 minutes and then send the results back into data. Right? So the dashboard will be a data pool. But we might want to do the same run, the same exact test with more browsers on a nightly run through Jenkins, in which case it will send the result to a more elaborate dashboard somewhere that integrates into the continuous integration process. The only two parts that are not independent completely are the test and the dashboard, because the test will generate the results that will need to be sent to the dashboard. So the dashboard needs to know a little bit what the test is going to send. In the open source version, we provide one example of that. So this is what it looks like now. The test, the callback, which means the address of the dashboard, and the number of browsers you want to use, along with the list of browser configurations, are provided to Kite. The conductor is going to check that the browser configuration you ask for exists altogether, right? If you ask for Firefox 128, it will tell you I don't have that and it doesn't exist. And that it exists in the grid you provided, right? So if you ask them for something that exists, like Firefox 43, but it's not in a grid that is attached to Kite, then it's going to tell you I won't be able to test that configuration because it's not a grid. It's not spawning in Nucleus for the grid separated. Right? The dispatcher is going to create the matrix of all the tests with a possible browser configuration provided. It's going to take into account the specificity of WebDriver. So mainly Edge and Safari WebDriver can only handle one browser at a time. So if you have a Safari to Safari test, you need to have two separate instances. Whereas if you have a Chrome to Chrome test or Firefox to Firefox test on the same operating system, then you can get away with having only one instance and do everything in parallel. So there is a parallel queue and there is a sequential queue to accommodate the different implementations for WebDriver depending on the browsers and transparent to you. And eventually, it's going to dispatch to the test runner that are going to run the test and send back the result to the dashboard. So what does it look like? The configuration file looks like a JSON format. side, the end can be whatever you want. The callback is going to be the REST URL to the server that is going to get the data in and send it to whatever visualization tool or post-processing you want. Most interestingly, the remotes are whatever setting of nodes you want. Here we give you an example of a local browser. Let's say I have a modified version of Chrome that I just recompile. I prepare everything on my local machine. I attach it as a local node. You have also in the open source repository examples of how to deal with browser stack, in which case you also have a login and a password, how to set up a virtual machine and attach to them, and so on and so forth. So you can refer to the documentation on that to actually set up your own read and start playing with it. You can pass as many tests as you want, right? So in that case, we made the simplest possible test, which is testing if the ICE connection status is going to stable or not, which everybody knows is not enough if you really wanted to write a real test. But the idea was to illustrate the slash on a very complicated configuration grid. If you can write the test in whatever you want, but you need to be encapsulated in a Java class, and it can be passed through the command line or put together with. And then we give the browser configuration. So the browser configuration follows the WebDriver naming convention. You can just name the browser, say I just want Firefox, and then it's going to pick up whatever version of Firefox on whatever operating system. The first one here on the list. But you can also go all the way to say I want Firefox 33 on macOS X 11. In which case it's going to go and read and go there. So the maximum level of granularity is browser revision, operating system. You can say you want some alias as well. If you just want Windows, whatever Windows, but Windows and is going to find it. So all of that again is documented. So this is what it looks like. That's what it looks like. It looks there now. This is the default dashboard we provide in the open source. It's just a web page that is going to show you each of the runs. Green are the number of tests that passed, red are the number of tests that failed, blue are the number of tests that were not run because of an engine failure, either browser stack timeout or we couldn't find the configuration you asked or something like this. We thought it was really important to differentiate. The test was run and failed, then the test was not run. You're going to interpret that differently. On the right-hand side, you have the list of the browser configuration that we're using in that case. So Firefox 55 on OS X 10.12, Chrome 60 on Linux, and so on and so forth. So that's a very small subset. The biggest run we ever made was close to 2,500 pairs. So not bad. Then you can go into details, and eventually you can have aggregated results. Not only you have on the left-hand side the representation of the configuration, so blue to red, top to bottom, and then from the middle out you have the first browser, the second browser, and the result. So I'm going to show you actually the website. On the right-hand side, you have the pairs that were used, right? So you have a list, whether it failed or not, and the time it took. So we also have a lot of things, including the time to check for performance regression or things like that. This might but still fast, but then it's time slower. And one of the biggest bugs that we had that was WebRTC on like 20 different. Most of those failing here are involving since Edge, the permission prompt, but always fail. Browser in a pair, then you will Right. So we want to keep going on Cisco Spark. So here is, for example, let's put it in the to 5 browser configuration. Fine. The matrix. But of course, we took the configuration that worked, right? All the available. And I'm going to show how we can interact. Where you want. On the first one, that's going to automatically to give you only the root when the first to call on the second one to Chrome. I can either click here or click on the icon on top is going to be on the third browser to and okay, with something that's advantage to go from just when one of these here starts to be small configuration, even with one, they say I want to start. And what is very interesting for QA is that you can manually say, no, but a lot of people are interested. There is the first thing. Therefore, email for you go, right? 1,000 is the number that the GP can 1,000 is fine. But what's interesting for QA, not interested in, might not be interested in do that. So very quick introduction to a lot of things coming. So the goal of this first attempt was to show that the engine was but mostly those that had never been done before by of course, I mean just checking just the isolation of WebRTC within the limit. That's nice, but okay. Something right? Also, we want a mobile browser, open source. We're working a lot with Chrome and all kinds of people was nice enough to open source WebDriver compliance framework for Qt to connect. Chrome has its own Chrome driver that was only done by inside on the desktop browser, so mobile native or IoT possibility. We're going to provide tests for one-to-one with G2, SFU, simulcast, and to test some part of the web. And so very open. There's no better app in testing than the error they're getting with the browser vendors. Helpful and all of us around the table here. So do not hesitate to go and start putting figures. Very, very welcome to send good ideas. We don't know everything, we don't know all the things. Help us make it for questions.
Okay, so given challenges like, hey, where do we run a bunch of Apple tests, and what do you see as the next steps? Not just for, I mean, first of all, thank you guys for doing this amazing amount of work. It's awesome, really. But what happens next? So, what do we do over the next year to get to
completion too?
to get it? So we're bringing that up to 100% test rate. Right, and are covering whatever, or actually, I should maybe even ask something, like, what is the testing we need to get to, and how do we get there, and how does this help us? What happens?
I think in terms of compliance testing, that will bring us very quickly there. 100% on all the browsers is a little bit challenging. We need to give the WebDriver permission, WebDriver. That's happening tomorrow. As a first implementation, sure that can be done. I think Kite will be more useful to test the IT aspects that are needed within the WebRTC. Beyond the really only things that is working right now are some a few stuff related to eyes and the simulcast part, right? And Kite will help for that. So I'm more interested in beyond WebRTC 1.0. If we want to get stable, if we want to avoid all the critical bugs and so on, this is not by testing the JavaScript API only that we will be able to. So I want to have more tests. We're going to start with get staff and things like that. And I want to have more instrumentation. I mean, there is a lot of. This one doesn't work? Is it better now? Right now, people are focusing on code quality. Right, that's the next step. Neil did a wonderful presentation at TV last Friday about the influence of network reliability on code quality. There's a lot of problems with the bandwidth management and bandwidth estimation and processing. So I need some capacity to the certain way to instrument the network capacity. I think it will be something I would love to see. Beyond that, beyond the code quality, there is the media quality. It's still very difficult to have the computer evaluate the quality of the video in the same way as human does. There is a gap benchmark to whatever might be. Well, as far as the Senate, there is the opportunity to do more end-to-end testing, but unfortunately, there is a lot of RFCs involved. So if you and all the interact with each other is going to be complex to analyze.
Well, I think getting 100% of those would be like possible. You can really see my draft on the number of RFCs we reference, right? But I think that getting some important, I'd be very happy to help on picking some important use cases through there and trying to make sure we had it. There's also a bunch that could be put forward on perceptual media quality.
Yeah, so I just want to highlight that. So we from Google side, we will like sponsor all the third of Kite, so we can actually get like a proper test suite in there. And so getting input on those use cases, the important use cases, is really important, so they can prioritize the work on it. And although Kite can be like used for testing very complex and more proprietary solutions, where we demonstrated it's important to get please anyone provide input to this worker, and it will be like very hard to get to be RFCs. So hopefully we can get the base right. So
can you say a bit more about what test case, actual test case? You expose
The part of the Kite have two or three so it's two better edition and better documentation about how to rank tests. I think that one is so it's coming towards the end of the load at IPF. That's going to be tight, and we might just put
particular how hard or easy to run their system.
because I can run any tests.
mentioned that like the goal is to get all the platform tests run possibly because it's much more controlled. While it is still useful feature, I think it's much in depth sort of all the other.
our nodes directly. So,
There is an effort to bring
Aaron, can you hear us now? It's okay.
Now I can hear you. It seems to help if you talk straight into the top of the mic instead of trying to talk to the side of it.
I will try to do better. Any questions from WebEx or from the room?
Top of the mind, okay. Well, I think, are we going to have the tutorial on Kite as well, or no? So we're basically, I guess, done with this public session. And we'll be going back into the TPAC meeting, so those of you who are registered for the W3C or members can join us on the official WebEx. Thank you, everybody.
Well, let me just go over what the schedule is for the next 2 days, since we lost a whole bunch of vacation time to, so, here's what we're, yes, you can close that WebEx. I'm